function. We start with the user options, male, female, max, min, amount of names. And so around here, we just have the fields being set. Here is where the scanner, here's where it takes the input. And then here's just checking the inputs. And then by this line over here, it tells Markov to generate the names. So that's where we're going to go next. Okay, so again, starting from the top, it's actually a pretty simple file. I didn't end up using a whole bunch of different data abstractions. I just made it a simple line. So we start off here declaring the names content. All it does is store the information from the files, and then I was actually having some problems with the with reading files, so I just gave each files of all the names down here. So here I'm storing the initial names as an array, and then it moves over to a list over here. Here's where we're creating a list of the individual characters, and then we create the double characters in a string by combining each character by iterating over the list twice. Here's the main map. It's made up of a hash map of a string and then another hash map of a string and a double. That way, as we're about to see, we're going to put the frequencies over. We're going to put the string itself, and then the next character, and then the double. So you have a main list and then sublists and submap in each of the entries in the main map. Okay, and then so here we're inserting from hot cars, which is potential characters of all the different combinations. So this is the first list. All it does is just all I'm doing right now is creating a new list for the letter frequency. And here I'm setting the letter frequency. And then here is where we're inserting the frequency for each name in the sublist. Again, using a list and then a hash map, going through each word. For string ent in the names array, we're setting characters to each, and then for every time you see a new letter, it increments. Here is cur equals cur plus 1 in the map. It increments the amount of times this particular sequence happens. We are going in and we're dividing in the first list. We're setting it to a probability from 0 to 1. In the first list by dividing by the total amount of names, and then here it's down here it's we're dividing from here is the total amount of times that this word shows up. And so now it's on to creating the names. What we're doing is we're creating an array list of names, really just a list of names if you want to go by the interface, and then it does this whole block for every until the amount of words is filled up as selected by the user. And so here again, we're just going in and setting. We're figuring out which are the two sequential words, and it does check for the start and ends because of the end character. And then here it actually goes into distributed random number generator, and we're going to go into that class in a second. I'm just going to finish up explaining this class. And then it appends the next string to the ret list, and then we print it out. So now on to distributed random number generator, taking the original map that we sent in, adding it to a new structure that's called map. It's a navigable map made up of a tree map. And what we do is we switch the order of the original map, and we make the new map a tree map of a double and a string. And what we do is as opposed to entering the actual probability, what we do is we add successively upon the previous non-zero entry. And by calling the methods in getString, when the main Markov function wants to get the string, what we do is we call ceiling value, and then we call get value, and it ends up returning a string by its probability.